Everyone, are you able to see the screen?
Yes.
Yes, we do.
Okay. So I'm Kylie.
I'm June.
I'm Bruna.
And we started with 2D to 2D style transfer. So these are some of the examples of the input and output. This first one with falling water as an architectural example, and an exterior photo, and then the interior of La Sagrada Familia, and how changing the style weight could affect the color and texture of this final output image.
Yeah, and then right below, you can actually see the difference between lightweight on style and then heavier weight on style. So the top one, or the leftmost, is less style, more content, and then more style, less content to the right. And right below that is an interior of a minimalist apartment in a Baroque style church. And that's the one I found the most interesting, actually. The first picture on the left is the Baroque style and the minimalist. And then I reversed it for the one on the right. And it came out with this really kind of eerie interior of the church.
And for this one, like we are interested in reverse the input, like reverse the style and content to see maybe could get a guess about like what the neurons are doing. So yeah, it's a general sense.
And we also explored 2D to 3D style transfer. So these first examples, one with more of a complex mesh object and one with more of a simple cylinder, and then inputting different images of either architecture or from nature, and then getting different animation results in terms of the texture and the coloration.
Yeah, and then in these examples, again, you can just see a bit of the difference of when you increase the weight. The top one is just another nature example, but in the architecture one, the bottommost, Kylie, if you want to play one of the animations, it looks pretty strikingly different from the middle one, and that's only increasing the style weight.
Yeah, that's just another trial for that, and we kind of discovered the mesh of the model kind of decides the output, the image size. So yeah, some weird results out of that.
And the last kind of exercise was the deep dreaming. So this was like the same 3D object and an animation with, I believe, about 300 iterations. Sorry, it takes a little bit to play. There's that one.
And then again, like the other ones, these are different models, but as they go down, they increase in weight or in iteration. So more deep dreaming has been done to them. And you can see the result of the 3D model on the right. The topmost looks pretty much the same as the input model, whereas the bottom one, if you zoom in a little bit, you can see that it really starts to have bumps and edits to the actual model.
Yeah, and this one is we want to go back to see like how many neurons do the algorithm we have can be achieved, and we choose 3 of them like to show. If you zoom out, like they basically seem the same picture from the like original one. But if you zoom in, like you can see the differences. Like each neuron have like make the manipulation towards the original like pictures. Yeah.
And we also each took a different chapter or like research book or article. And so the first one was from Inventing the Future, Chapter 7, A New Common Sense. And some of the key ideas were describing a post-work society, the concepts of basic income and automation, and how these problems of automation and surplus are global problems. And the proposed way forward was this counter-hegemonic strategy, a project to overturn the dominant neoliberal common sense and rejuvenate the collective imagination. So there were kind of 3 parts. One was about utopian narratives, how utopias can be a catalyst for change. A second about rethinking the economic system. and the third about repurposing technology. So how we can repurpose existing technology, igniting new collective imagination. And this kind of call to action was so we could transform a common sense of society, revive our utopian thoughts, and yeah, like I said, rethink the economic infrastructure on how a post-work society could work in the future.
Yeah, and my chapter was Neural Nets and Insect Intelligence by Manuel Delanda. It was really interesting because it taught us kind of the background of what's happening in these neural nets while we're doing these style transfers and different training. So while the example was about insect limbs, it really just taught how a neural net can be trained. And the basis of it is that sensory neurons kind of receive information and then send information to motor neurons, and you can train them to either habituate or sensitize to different information. And you can simulate in a computer through different units that are just responsible for knowing their own activation, and then connections that change the weight of these activations and information. So that image on the top, on the right column, just shows like a more intense neural net with hidden layers. And in that, you can just give it an input, give it a desired output, and it trains itself to have the weights necessary to recreate that output by itself.
And then these are some ideas about our vision going forward for the next semester thesis.
And for sorry, for this specific one, like what pulls trigger is that like this group of people see the trend that like the 3D animations will becoming more and more popular. And the truth is like making the 3D animations will be so expensive. And the other thing is like 2D version of the same animation often like exist already. So they try to explore the possibility using AI to make 3D animations out of those 2D versions. And they tried like 3 different methods. And this one specifically maybe related to our domain, which is they try to use a 2D image to engender some sort of like 3D mesh and even can animate them somehow. And Kelly, if you can play the video a little bit. And yeah. So as you can see, like from a single picture, they can animate a whole mesh and have them like move. Like if you wait a little bit, you can see they even apply this strategy into an AR environment, so that like I guess it's more related to architecture somehow. You just skip the AR part. Okay, that's okay. That's yeah, as you can see. Okay, that's enough.
So our overall interest as a group is interested in 2D to 3D or 3D to 3D optimization techniques. And we kind of divided this into 3 interests or directions going forward. One kind of major area of interest is circulation and flow. And one way we thought about this is at the scale of a building. So thinking about like designing an airport, different optimization factors for an airport, and how we're interested in circulation and flow as this overarching topic to gain ideas about the gates and general layouts. So this image here is a diagram kind of showing like overall configurations or layouts. And this here is kind of a concept diagram that's discussing essential principles for airport circulation and how like predicting is able to help them control passenger flow. And we thought it's really interesting to think about like the relationship between infrastructure and the flow of people that are moving through the space. So the relationship between the user and the space, different passengers, different purposes. And here are some examples of images of airport configurations kind of as a basis of study or precedent of study. And then also looking at spatial configurations in terms of like aerial views, some international examples, as well as some US examples. So an idea about like classifying an original figure, and then using AI to come up with designs through training and precedence.
Yeah, and a similar idea, but at the scale of a city. We've been talking a lot in this class about how different devices that we already own kind of already track your every move and sends it to someone, and who has the right to own that information, and the different ethics behind that. And this I thought was a really cool example where the bottom images show it a little better. But using that information of just people carrying their cell phones while they run, they were able to create a database of the most popular running paths in 22 different cities, I think it was. And so the idea was, how can we use that kind of information that we already have of the most popular tracks to optimize the path, and create a city that already has these optimized paths. And the third one, just in trying to decide how really to step forward, we thought we should come up with a third interest, and that was outdoor and green space, mostly at the scale of a building. This example right here is the case study of a city in China, but in taking that kind of idea and trying to put it in the scale of a building, is it possible to create a database of these really interesting relationships between a building and a green space, and then create a ultimate form that has a quote unquote optimized relationship with green space.
Thank you.
Yeah, thanks.
Thanks.
Great, thank you very much.
Amazing. I mean, this is quite an overflow of information. And you did really a lot of, you put a lot of things together, looking also into very diverse things. I would like to start with some of the later things you were showing. I think, honestly, I could imagine that when it comes to circulation, for example, yeah, I really think that is a very interesting field, because you could probably study on various, let's say, precedences or cases. You can study how people move, or even if you say how swarms would behave and other things, and you could try to learn and extract features. And maybe, hopefully, you could also translate that into spatial configuration. So you could either avoid or narrow or bad situations where
you can reconfigure space, yeah.
Genau, where you could rather find solutions to problems which we otherwise would have to translate. Yeah, because so far when we use simulations, we only can read out the colors or the numbers we get back, and then we have to interpret them in order to make decisions. Now, this could be here much more smoother and direct translation into spatial configurations which are automated or deduced automatically. I think that is I mean, it's a more technical aspect of it, but I think it's something which I could imagine could work very well.
You know the certain measures project, I assume, right? Where they looked at the airports, the footprints of airports. And I think they used, either they used the SOM or the SOM network that Ludger Hobestad develops at the ETH, or maybe they even just used, I don't know, Inception or something from just Google, but they were collecting all airports worldwide, the footprints, the top views. And then they were sorting them, so they're doing some clustering with them. And it was really interesting, because at one glance you have all the typologies there, but it didn't go further. And I also agree, I mean, I was also noting down that what I have to say I really like about the agenda of the studio is that it has this broad agenda. It looks at the cultural, the aesthetic applications of AI, even, you know, what style could emerge from it. how could it become a creative tool? But then there's also the idea, which comes, of course, when you deal with machine learning, what's the technical application that's in there? Because there always is, right? And I think you have a certain point where you start to mention data. And it's interesting because I think when you come to optimization, you probably need also a lot of data, or it needs to be much more specific when it becomes more the creative tool of exploration, when you deal more with style and what will happen to our visual culture, right? Then you could probably be more explorative and open with that tool. So I think at the moment it's still all there. But I think what I like is that you're very aware of that already as students. And I think that's great, because you really need to be, with these tools, at some point you need to really know what you're using them for. And I think it will also have to do a lot with your workflow. And what I would suggest is try to draw your workflow within your scenarios. So what tools would I use when? What data would I use here? When would I be open? When would I allow myself to become creative again and explore? Because I think we're very much used, or our generation was used to very much to these consistent workflows. We were trained, if you do NURBS, then you stay with NURBS, you don't mess around with anything else. But now I think tooling becomes more messy, and that's great. Doesn't mean that you don't have to be precise and aware. But if you draw your workflow, you might find out, okay, give me a second, I need that, maybe that clustering, because I look at site plans of all the airports. Then I go into classification, then I use the images to do that. Then I need to do a 2D to 3D transformation. So I need another tool for that. But you need to be aware of your workflow. So really make a diagram, maybe. At least that's what we do also a lot, to really find out how do these tools relate to each other and what data is produced where. And I think one could really allow oneself, because that's so new, the field, right? So nobody knows how to use that in architecture, right? I think it's really the intelligence needs to be there, your design intelligence, right? So you need to know why you do it for, but otherwise you can be really messy if it's a targeted and purposeful messiness. I think it's great. I like it.
Are you planning to integrate all the research and all the different things you had a look on into your thesis? Or is there something you could imagine which is probably, or do you have, let's say, the most important ones, 3 of them or 5 of them, and then there is some which you say, they could be, or maybe, or they're more something you had a look in, but at the moment you don't see them playing a major role later on, because it could be quite challenging to put all those aspects into one thesis project, and it could be quite an overload, and probably some of the ideas even are in concurrence to each other. Could be also a good thing, but it could be very challenging in the end. So I think it also makes sense to focus on the main ideas or concepts which are really carrying the thesis, and then probably focusing also on that and leave the others maybe a little bit more. Don't forget about them. Maybe they come in later. You never know how a thesis develops. Yeah, but I would make more preferences, I think.
I also agree. I think looking at what your intentions are and then looking back onto your pool of possibilities might make sense a lot, because sometimes your application of AI might also be at some points, a simple one. Yeah, I think because you for some, maybe you just need at some point, you just need these top views and you need the silhouette of it in order to create data for the next step. So maybe use something very simple and very banal, but then you use it in a clever way, right? So I think, yeah.
I mean, the last point here, the outdoor green space, could be really interesting if you go into master planning or large scale interventions, because I think now we need building regulations in order to find the right distances between masses and axes in order to connect certain areas of the city. But you could also make this very differently, I guess. Yeah, you could find new rules or define new typologies of a city, even in order to learn from the right sources. And I think the ratio between the green and the buildings and the views from the buildings outwards could give you a great input in order to find new distributions.
I would like to echo one of the other comments from Christina and Stefan, because I agree that like the three interests that you lay out, there might be the necessity to consolidate it to one, because I think that it's better to focus on one and create a very solid idea rather than spreading out through three and then have it half developed at the end. So I really completely agree with that. And there's, of course, always the questions like, yes, we have the technological part, but I also think that when you think through the problem, as Christina was alluding to, like when you really sit down and analyze the workflow, you might figure out that there is a part of it which was not covered in the basic ground course that we gave you, but we still have the possibility to get it custom made by our friends at Computer Science. So they could actually help you to develop that idea. So when you say, I would specifically like to analyze the flows within an airport and how to optimize those, then they can help you really getting there. And they will also tell you which kind of data you need. And I also think that if you select one of those options, the chances are better that you have then a database of 10,000 airports that you can use as a basis for the process, instead of having from each one of those maybe 500 or 1,000 examples, because it's just too much. So I think that it's good to focus on one thing, and then the other one is keeping in the back of your mind your readings, like what is an airport in a post-work society? Do we need airports? Do they become smaller? I mean, if we consider our current situation at all, like what's going to happen with airports in next year, even just next year, I'm not even talking about 10 years from now. Yeah. So this is an interesting proposition to analyze and predict what architecture does or where it can go with the data we have now. Yeah. So it's yes, that's the analytical part, and then the part of how do you, let's say, reverse the flow, so to speak, and make a design tool out of it. Instead of an analytical tool, it becomes a design tool. Like how does it create stuff? Yeah. Remember, for example, how deep dreaming, and we had a long conversation about deep dreaming and how that works actually, and that the reason why these weird images are generated is because the flow of information is reversed in the neural network. So it doesn't have to analyze things, it just needs to make sense out of things, which is two different things. Thank you. Thanks a lot. Sandra, anything? I don't know. I think Sandra's in another meeting.
Okay.
Okay.
But there are also some aesthetic investigation at the very beginning, which are also very interesting, I think.
Sorry, I was just muted.
Ah, you were muted. Okay, I was thinking you were in another meeting. I heard you speak somehow in the background.
No, it's brilliant. I don't have to say anything anymore because the jury totally agree. But I also, at the moment, it looks like you, the three of you just pushed ideas forward, which is great. So each of you proposed one idea. But I agree with the jury. We have to just fuse this into one project, into one cohesive project. And here I would also go back, probably if you scroll up to your theoretical part where you analyze the books or the articles that you've been given. I think that's where your story should come from. So I think that's really important, that the ideas that you go through in this book are not lost in your project, but are really triggering the project actually. And you just have one example as proof of concept. So the ideas, and that's very similar to how neural networks actually work, because we're using just one model to say to understand whether a student or not will pass an exam, as well as to understand whether or not an email is fraud. You know? So So sometimes we're just using the same model which we see here onto the right, you know, with the input X and the weights, and then you have your on the other, the right, yeah, down there, the weight update and error. Yeah, that's where you have your sigmoid, you know, you have your loss function, and then you start to understand, you know, what parameters do I have to change to adjust, you know, the weights and the bias so that they actually translate back to the in and output that we already know. So what we expect, you know, it to be, or what problem it tries to solve. So I think that's really something you need to find your problem right now. Yeah. So and the model is not such a problem. I'm sure that you will be given a model and that you can use your problem, but really try to knit out of your readings a cohesive story that merges into your project. So you really have a story to tell. And none of the projects that you do, whatever decision you will make, you cannot make a wrong decision. It's just because if the model is designed correctly, then actually it should give you the results you're looking for. The sooner you make a decision, the better it is for you, because then you have much more time to train the system and to generate the database necessary. Okay, that was my 5 cents.
Awesome. Yes, I think we can move on to the next group. Thank you very much. Appreciate it.
Thank you so much for the feedback.
So it's Jacqueline and Peter.
Hi.
Daniel has arrived.
Hi, Daniel.
Hey, Daniel, good to see you. Yes, there's our additional guest, Daniel Bolojan. Welcome. I think I made already a brief presentation about you before. So Daniel is AI design wizard from Florida right now. Daniel, can you repeat again which school you exactly are in Florida?
Florida Atlantic University.
Okay.
All right, just to kind of preface this, we followed like a similar, I think all of us followed a similar format of kind of like outlining individual explorations, which are like the top 2 rows here. And then we kind of got together for some like collective directions. So the presentation is going to follow a little bit of that structure as well.
So we essentially went through similar last group and did the 2D to 2D neural style transfer, and then just played with different line weights, and we're able to like export different results. And then the same for the 2D to 3D style transfer. And we got different results by applying an image to a 3D structure. And then we did the 3D deep dreaming. And it was interesting just to see the different results based on like different line weights that we had used. And then Peter, if you want to go through and talk about yours a little bit.
Yeah, I think Jacqueline kind of covered like all the kind of aims. What was interesting for me in doing all this work is looking for like the point at which things started to really become deformed, and what the kind of like parameters were for changing something into like more of a hybrid or something less recognizable as the original. So in the 2D style transfer, was playing around with kind of even distribution of weights, emphasizing content over style, and kind of seeing what happens as it iterated through that process over and over again. With the 2D to 3D style transfer, it was similarly a question of weight. The proportions in like the top 6 were very heavy in terms of the object and not the texture. And then down below is where I like kind of found that like a more even distribution could really start to actually deform the object itself and not just the, Jacqueline, can you zoom in a little bit to the bottom too?
Yep.
To deform the object, which was just this kind of simple twist even more. And then over into deep dreaming, I progressively went through systematically from like 30 to 100, 300, all the way to 5,000 iterations to kind of see the evolution of deformation, which was kind of interesting to see that within the parameter of iterations here. And then
And then for our readings, I went through and read New Dark Age by Brittle, and I read the chapter Complexity. And it was interesting because he was seeking to find where digital technology becomes physical materials. And he explained like in depth how technology is a key driver of inequality. And then he studied how computation is increasingly layered across and hidden within everyday objects in our lives. And with this expansion comes an increase of opacity and vulnerability.
I looked at the second digital turn by Mario Carpo, and what was interesting to take out of this is kind of the evolution of how we design based on the technology that we have. So the left column, he goes through the history of how we went from data poor to data rich, how methods of making by hand with kind of bendable wood and shipbuilding could interpolate points along curves based on a couple control points, and how similar kind of methodologies were implemented into computers so that it could be done iteratively, but in both cases relying on kind of interpolation of data to get surfaces and curves and things like that. And he identifies this moment, which is kind of exemplified by the Michael Hansmeyer image on the bottom, where we now have so much data that we can conceive of designs and points and voxels and things like that. So this kind of transition from data poor design to data rich design is something that is pretty influential for us going forward. So in terms of like collective direction, we're based on like the title of the studio, we're interested in machines with vision, kind of a play on the title. These are a selection of examples from we're mostly a lot interested in the LiDAR data and kind of machines sensing the environment through point clouds and an excess of data. So these are just this is a point cloud of New York. This one is a point cloud understanding the terrain through this spatial data. Apple just a couple days ago released a new iPhone with LiDAR embedded. So this is just this kind of highly detailed level of understanding the world is pervasive at many different scales, going all the way to facial recognition, AI, to Amazon Go, to smart homes of the future. And this kind of ability of AI to synthesize and to analyze this information is where we're interested in. We're talking a little before about like AI for analysis versus AI for generation. Right now, we're a little in like looking at AI in terms of what it can analyze and how it does that, and how like AI through that has some kind of cultural agency that influences how we behave as citizens and how architects can engage in kind of political narratives of space around like the politics of data, information, and kind of engaging with the systems of power that kind of hide behind those. So, and we kind of see it looking at the Norbert Wiener and the Panopticon over here. We kind of see it as an evolution of, this is the beginning of kind of understanding the history of humans and machines, and as part of like one system, and also like broader like spatial apparatuses that kind of embed surveillance within them. And that's the reference to the Panopticon and Foucault as is necessary when you're talking about surveillance.
So then to essentially kind of summarize what we're interested in is, we're interested in using LiDAR data to augment the prediction of energy performance and the state of IoT technologies within a building through machine learning. Because massive amounts of building operational data are collected and stored in modern buildings, and this provides like information for in-depth investigations that we're interested in. And we want to apply this machine learning technique to improve decision-making process of buildings over its entire life cycle. So we are interested in using these techniques to provide fault detection, diagnosis, and energy efficiency improvements. So our solution proposition offers a seamless transaction between architects' goals of projects and the business or organizations that are like implementing these goals or like using them. And then So we pretty much want to take the raw data of LiDAR and IoT sensors and then analyze the LiDAR data potentially with DTM and DSM, and then combine that with the IoT sensors to make a smooth or like offer solutions to the people that are actually using the buildings. And we were looking at this at like a bunch of different scales. So we were looking at like a large, like citywide scale, or like for individual buildings themselves. So that's pretty much where we're at.
Great. Thanks a lot, Jacqueline. Thanks a lot, Peter.
Did I get this right that you would like to work with the LiDAR data, like point clouds from that, in combination with data you're getting from individuals inside of the building? And that sounds really interesting because, you know, I mean, all these kind of laser scanning point clouds are still, let's say, describing surfaces. But point clouds are actually a very powerful geometrical system because they are able to describe things in a much deeper three-dimensional way beyond surfaces. So you can actually go and look inside and have a much more deeper three-dimensional understanding of objects if you use them right. Now, using data from people inside the buildings sounds to be probably, or could be, the key in order to get this deepness into your point clouds, which also only describing surfaces, but you would combine them and hopefully could get a more and deeper model and understanding of what's going on. I think that is really a great setup. The funny thing is we just had finished a research project, a collaboration with the city of Vienna about heat spots. And we also were using laser scanning data and stuff like that. So there is a lot of things in common.
And we also, I don't know, maybe you have do you have a GeoSLAM scanner available? I think they're not that expensive, right? I think it would be, I think it could be really fun in really going into scanning yourself. I mean, even what you said, that the new iPad and new iPhone, they all have it. That opens, of course, also the chance to use AR on these devices, right? That's why they implemented it. But also, I think I would look more into the tools that are available with point clouds. I mean, for example, there's one really nice online viewer we use in our project also, that's called Poetry. But there are also many others, and there are quite cool algorithms at work how to deal with these huge data sets, these huge point clouds, and that work a lot with the perspective and the resolution dependent on the distance of the viewer. So there's all these, you know, when you say visionary machines in terms of vision, right? Then that has a lot to do, the point cloud has a lot to do with the ideas of human vision also. So I think that maybe I would even suggest to go to replace your readings or talk to Matthias again about whether the Mario Kart, I think, is a good start, but he doesn't have the deepness in that in a sense. So I mean, I love the book, right? It's so great he's so radical, but what he says in the end is, okay, so now we have all the chunks of reality, and so now we achieve a new kind of resolution, and I think he's right with that shift, that rift even that's happening there. But then what do we do with it actually? So and maybe I wonder if it needs to be that huge scale, the city scale. Maybe you reconsider it, because you said making is also interesting for you, and I heard that you do a lot also with robotics. Maybe you go into that. You said something about data-rich design, but what about data-rich fabrication? You know, I think I think going into the big scale again might even, I don't know, bring you away from these possibilities of the point clouds and these understanding of these depths of a space, and then maybe even, I don't know, robotics and fabrication. Or it could be really fun to even develop that into a new book. Like, you know, I don't know if you know the book by Rudolf Arnheim, Visual Thinking, where he explains how human vision is really related to how we think as humans and as designers. But not what happens now when machine vision comes into that, right? And then it's so weird because these machines are made by humans, but then they, you know, they have such a completely different understanding of reality. They develop their own even. So yeah. I would love to see that comparison in a way. So maybe change the reading a bit, like go deeper there. Yeah.
But it's definitely the case that we get more. I mean, point clouds had been a geometry system only for a few, for scientists, but now and geographers and specialists in some branches. But now they become more and more available, and they will. I'm not sure if they will, let's say, replace the images. They won't probably, but they will get much more room, and they will get more presence in our daily life. So I think the move to look into that was a very clever one, and is definitely a very interesting field. The computational power will be massive. That's for sure. But they have a
CPU to use.
I was wondering if you could talk a little more about the point net that you mentioned before we started. Is that something you've been working with? I saw it on GitHub. I just looked it up quickly.
We just started, and what our PhDs did, they rebuilt it, or they looked at the code and the training data, and then they trained it. And it's a 2D to 3D translation, right? So you give them an image and a mask, and then he tries to reinterpret the image as a point cloud. And it has several limitations. For example, that it is trained on a certain amount of points, and then it can only represent a certain amount of points, and this is very limited. So at the moment, I think we have, I don't know, 10,000 points or something.
Yeah, you're very limited in the amount of points. That's why it is very complicated to feed in laser scanning data with millions of points, because you have to reduce them drastically in order to get them into the system.
But then there's much more out there. I mean, I put it into the chat. We can put the paper that is a quite recent one. It talks also a lot about morphing between point clouds, for example, and that is something that is also possible. So I mean, there are many more procedures and things to points and 3D point clouds at the moment. The point cloud and point net is I think it's very young, and apparently it is a bit tricky to work with it, but I'm sure you have the experts there. So I would just recommend talking to them. Yeah.
Hi everyone, great job. I really like the steps that you went through. I'm just wondering, in a way, if you can look also at this exercise from a different perspective, not only pure vision, because right now I think we are looking at vision just like what we understand as vision, but machines, they are more capable, they see more than we can see. So for example, when it comes to space, I think it's also interesting to look at actually what you cannot see. It's almost like this kind of idea of survival bias, where normally we as humans, what we are doing, we are focusing on things that survive instead of the things that didn't survive, for example. And most of the time it's happening that the things that didn't survive are more relevant than the things that survive, for example. Yeah. So I think maybe also in this kind of aspects of how you see or how you perceive certain things in a space, most of the time the things that you perceive maybe are not the most important. Maybe things that are behind, like are hidden to your naked eye, probably those are more important. So it'll be interesting then how you combine this kind of LiDAR kind of point cloud, which is very visual kind of thing, with things that are not so visible to your naked eye. Yeah. So I'll just in a way challenge you in a way to try. What if you look at also those kind of things? Yeah, things that are not visible. What's the impact of that?
Yeah, maybe to add to both comments, which I think were great. Thanks a lot. There's like a whole conversation in the seminar and also in another course that I do about something called post-human perception, which is basically what this problem is about. Like, and we've discussed on several occasions that machines perceive the world differently than we do, and that there is something very psychedelic about the way how they see the world. It's really funny when you talk, for example, to these people in robotics and computer science, how they, the language they use to describe the way how machines see the world is all connected to psychedelic vision, dreaming, hallucination, and all these sort of things. And that has, and the scientific background on that is because they themselves borrow these terms from neuroscience, because these are the parts of what we think we understand about vision in our brains. It's not completely settled, by the way, whether this really works like that, whether vision or perception works the way like that, but at least they can take those cues and transform them into formula, into mathematical formula that they can use then in software. So that's why they're using this sort of terminology. But to Daniel's point, absolutely, there is like this completely alien possibility to perceive the world and operate the world also around that sort of perception. And I'm sure that there's going to be also more projects in the studio that discuss those possibilities. One thing about the Mario Carpo thing I wanted to add, which is interesting. So I completely agree also with Christina's argument here that, yes, we exactly discussed it along that lines, where we pointed out that Mario Carpo doesn't mention the word AI a single time in that book. So he completely oversaw it, yeah? And the reason, yeah. What is that?
I guess.
And the third digital turn will come out soon.
Yeah, most likely that's gonna be it. Yes. Anyway, he completely oversaw it. Yeah, but I think that one of the reasons is the book came out, I think, 2016, and all these sort of things like generative adversarial networks were basically invented 2015. So it was too early. He just didn't see it yet coming. Yeah, although there was
it's always the same with him. He's always that's always the case with Mario. He's always
he's a historian. He's a historian, so I think it's really fair. He claims not to be a theorist, you know.
Right, that's true.
And he also does not claim to be a computer science. He explicitly said he's not talking about AI because he's not a computer scientist. He's an engineer. So that's why his framework is probably discussing it on a different basis. But
funny enough, if you think about that statement, computer science is actually a subdivision of electrical engineering. Yeah. So, anyways, I agree with that statement. I think this is, but we were intentionally also using some of the readings not as something that just goes into a positive direction, but also to criticize it. And Mario's book definitely was one where we were criticizing that he left out an important part of that whole development. Although his whole notion about big data was interesting, because he was saying like, there's so much data and what can we do with it? And now we have this AI techniques that allow us to dig deep into big data and do something interesting with it. Yeah, because it's not just about, I also like his notion, for example, explaining why the architecture that emerged out of this research is messy. And you mentioned the term messy already once, Christina. So there is something inherent in that, in the thing, but that's a purely aesthetical observation, and it doesn't go deeper into the meaning of it.
It's just interesting when you read his first digital turn. It's very telling because he has, for example, John Fraser there, or even Philippe Morel. And then in the second digital turn, he leaves those out, right? It's interesting that he's already describing that in the first digital turn, but pointing also at some, I don't know, he's more going then into cyberspace, which is funny because that discussion in a way, I mean, I even think that the trajectory between what happened in these messy times of the idea of mixed media models and cyberspace and these weird 80s experiments, I think that even comes back now a little bit. But I think I'm just saying that Mario is missing some trajectories he isn't aware of, or he's not interested in because it doesn't come from the Bartlett but from the AA.
Also possible. Well, what's the Angewandte to is these days? Is Professor there now, no?
Right. Ah, really? Okay. Maybe.
I think Daniel mentioned that you should focus on the invisible, and I think they already do in some case, somehow, because they were mentioning that they are interested in climates and heat spots in the city and stuff. So I think you are already on track. I think that is you have all the ingredients already.
Yeah.
It's the same comment as before. Focus on one thing to make that really focused and concentrated and polished. So figure out what's the one thing you're interested into, and then put your efforts in there. Great. So if we have no further comments, I think we can move on to the next group. Yeah. Thanks a lot, guys. Awesome work.
Thank you.
Thank you.
So let's see who's the next ones. And I think I'm not sure. I'm actually not so sure anymore about Miro. It's a little bit of a messy presentation tool. Alex and Andrew?
Yep, we're up.
Awesome. Thanks.
So we're gonna kind of flip back and forth between Miro and like a slide presentation a little bit.
Yeah. Thanks.
Yeah, so hello everyone, I'm Andrew. So today we're going to give you this midterm presentation of the study we have covered from the beginning of the semester and until now. So here's like a quick outline of our presentation today. I'm going to go to the mirror board for our, study the outcomes of our style transfer study.
So starting at the top left, this was the 2D to 2D style transfer stuff that I worked on. So I took kind of the Villa Savoy and did a few different kind of like style images. I ended up thinking that the middle one, which was sort of a close-up of some of the ornamentation at the Lakshmana temple, kind of came up with the most interesting result. Maybe we can zoom in on that a little bit, or Andrew, really quickly, where it kind of actually started to apply some of the ornamentation to the facade and different areas of the buildings. But then it kind of also looked at like, it started to do the same to the sky. So I thought it was probably the most interesting result versus the other two. And then looking at the 2D to 3D style transfer stuff. So the model that I took was originally an old studio project. So I kind of took this same image of the Lakshmana temple. I took the Seagram building and then some images from nature, snow, sort of like a forest view, and this sort of kind of like lava flow. And to be honest, I wasn't super excited by any of these results. I thought maybe kind of an interesting one was the Seagram building, where it started to take on maybe a little bit of kind of the curtain wall within the geometry, and then the lava flow kind of image ended up changing the form the most. So maybe that bears, is reasonable to look into a little bit more, but that was that. And then the Google Deep Dreaming exercise that I did, I took this kind of, again, this forest image, and I actually really enjoyed some of these results. Some of them were less interesting, I thought, where it kind of looked more like a filter over the view, but some of it really started to like kind of show these actual like hallucinations and like maybe affecting the actual sort of materiality of the image. I particularly liked this one in the center, where it kind of started to suggest like the forest as sort of a built environment, where it's almost like this sort of temple sort of look, I thought. So I thought this was a pretty interesting set of results.
I'm really sorry that the mirror board is lagging so badly. So.
I don't know if any of our guests are able to look on the mirror board themselves.
Yeah, but so
maybe if you let me share the screen for a second, I have it. Okay.
Sure.
Sure.
Good. Basically, that's the middle image.
And then actually, Matthias, if you go up to the top left one, I thought that was also sort of a super interesting result where it looks like it was maybe from a human face. And so just kind of applied it in sort of an interesting, like ghostly sort of eerie way. So.
But that's exactly where things like the database you're using to do this deep dreaming becomes very important, and also the reason why you have to do your own databases to do this. But anyways, keep going. I interrupted you. Sorry.
Yeah. So I'm just going to go very quickly for the style transfer study I've done. So so Matthias, if you can go scroll down and to the left a little bit to.
Where?
Yes. So that. Scheduled bonds building there. Yeah, so I was doing this, trying to integrate like two kinds of contemporary buildings that we see into just one image, and the outcome was really unstable, I would say. So I think it was the top right one, restorative one, like a very outstanding depth in this image. So you can. I always find like these. Style transfer machine, they are very in favor of cubes. So like they can always transfer this cube language into like other 3D geometry very well. And if you move to the right for the 2D to 3D study, and maybe hit the play button for these cubes. So like the base geometry is very easy. Two rings, interlock with each other. And I used the same, Hopper house as the first texture, and I used some classical calligraphy as texture as well. But I don't think any of these really turn out as ideal as the first one, where the cubes language really started to form in shape. Yeah, so that's it for the style transfer part. I'm going to dive into the Matthias, can you let me share the screen again so that I can show slide. So following on, I'm going to talk about our individual interest. Yeah,
go ahead, Andrew.
Yeah, so following on, we want to sort of talk about our individual interests very quickly and some research direction we had before really, converge as a group.
So kind of throughout the semester so far, we kind of occasionally come back on this theme of imagination and the question of whether or not AI is a form of imagination or does it have imagination. And so I think I might sort of suggest that because of the tendency for the AI to produce these unexpected results that maybe a human would not have thought of, that could be a form of imagination. So maybe there's a distinction between active and passive AI, where what a human does might be considered active and intentional. And the AI kind of has this passive imagination where, it's the result of a technological process, but still producing something kind of new. Yeah, I think we can. So the question is like, how can that sort of sense of passive imagination be used productively in terms of design? And so looking, if we go to the next slide, Andrew. So this was from the reading that I looked at early in the semester. So it was from architectural theorist Sanford Quinter. And he kind of, in his book, Architectures of Time, talks about two different morphogenetic models, or how ideas, components, and forms, etc., are created. So he kind of suggests this actualization process where these forms and ideas are created through difference of the previous, or combinations of differences. So for him, time becomes real as opposed to abstract through this complex interaction of different qualities and variables. And he calls the product of this process emergent phenomena. And so if we go to the next slide, the example that he uses to talk about how form is generated by difference and the production of emergent phenomena is the difference between how a domestic ice cube is formed versus a snow crystal kind of through the weather, essentially. So the differences are that a ice cube is formed by taking water, placed it in identical manufactured molds, left it in a temperature and humidity controlled space, or freezer. So the water freezes kind of at its extremities, it fixes the boundaries to the mold, and each ice cube is identical to the next, and it will be identical to all past ice cubes made and all ones made in the future. So there's no element of randomness or chance or time. Whereas with snow crystals, these are kind of formed through dynamic weather conditions based on the atmosphere, temperature, water saturation, humidity, those kind of things. And so these snow crystals form spontaneously based on a number of different variables, and there's no way to predict what a snow crystal will look like. And obviously snow crystals are never alike, they never resemble each other. So they're all very independently created. So going to the next slide, I'm kind of seeing this synergy between the idea of possibly a passive imagination and sort of like a productive passive imagination, and also this emergent phenomena perspective where there's creation through a combination of numerous or countless variables that are kind of native to that specific process or reaction. So I'm interested in that kind of that relationship and that synergy.
Yeah, so for me, I mean, just going through like so many times of the style transfer study with the paper space, tools, I was really interested to try to learn from the failures that every time the machine does. So I was really interested if there's a possibility to combine this, set of failure, so philology, with our further architecture, thesis topic. So first of all, I was trying to define philology. So if you look it up, it says like successful failure, so which is very confusing. But I think there's like a lot of significance to study from these failures because, it's always costing so much of time and energy to build a project, and all designers want to ensure that the project can be finished successfully. And I also wondered like how is failure weight by objectivity against subjectivity. So if you think about like objective failure, so does the Pisa Tower fail in terms of physical structure, or is it actual success as a culture, culture significance of the country of Italy, and so if we try to frame the discipline of the failure of architecture very rigidly, so let's say the demolishment is like a sign of failure, then how do we, quantify that so that we can measure that with data? I also think there's like a lot of advantages that AI can do with this thing because, so I read Mark's article about this, machine versus, human being, and he couldn't help praising that the machine it itself is virtuoso. And I also think, nowadays there's like so many outstanding simulation, tools we can use to, model these, architecture projects. And so here's like one case study or precedent. I want to talk about the Kurt Igoe public housing in St. Louis. So I think this project, just by studying that, I think it actually achieved to, meet all the requirements by the building codes, and it actually achieved most of the needs that this community needed to have. But just, only 10 years after its, establishment, the project totally, impressed people because of the lack of management and, the rising number of, social issues, bearing with this. So if I could, find like a database, studying many, demolished buildings like this and try to analyze the reasons why behind, I think that would be very interesting.
So we also have like kind of a set of research questions that we kind of have an interested in. And some of them, kind of are maybe a little bit tangential to what Andrew and I just talked about. But so the questions are, I'll just maybe kind of read them real quick. In a world becoming more reliant on automation, how could AI develop architecture through an automated process? And what impacts would it have? And, whether it's a good thing or bad thing, and which also has questions of subjectivity and objectivity. So how can a field of data be interpreted by an AI automated design process? What data points would be used? Could those be human or vehicle, whatever circulation patterns? Could it be weather, sociological factors, anything like that? Is there a way for a building to change or mutate in response to AI inputs or sensors? How would AI combine different architectural aesthetics from around the world? Could that create a worldwide style? Would a particular style emerge, again, based on maybe, different data sets? Can AI generate a method of sharing resources or breaking down social and spatial hierarchies? And then what are the benefits of a design result which is not predicted? What is the significance of the unexpected result? Again, does this result in imagination? Is imagination the result of a combination or relations of different parts or variables?
And this is our last slide, and this is, some combination or convergence that we came up with just by, thinking about like those, interests that we had. So, is there going to be some, imaginary figures, so some anticipations of, buildings? So trying to distinguish this from some harsh boundaries like building codes, like can we have some soft standards to measure architecture? And how and what data should we have together, from the present studies?
So another kind of possible project prompt is thinking about this imagination of variables. So how can AI be used to generate novel and unimagined solutions in response to a field of data and variables? And so a process might be kind of developing a database of existing conditions and then associating that with a set of data and allow the AI to sort of sort through these things and develop solutions which are combining all of these variables into a single novel or unimagined result.
Yes, and of course we also have some other thoughts, more or less relevant to our, existing prompts. So, do designers actually prefer human users to, quote unquote perfect AI in terms of user behavior? If so, and what failure do designers actually expect from humans? Also can build upon failures. And lastly, I want to quote from this writer, George Woodbury: "If it's not the worst of failures not to have tried, it's a true failure."
So, to me, it seems you want to write a book or a PhD about failure in AI, right? I think that's the comment that most of the jury had today to all the students, including you. I think you probably have the broadest base of interest, as far as I can see. Also, I think Matthias, you can correct me if this is wrong, but I think Manuel Elanda in his book Assemblage Theory critiques that now we're living in a time of complexity. We cannot speak with broad terms about problems. So I think if you just, Andrew, it seems that you are most focused on the terminology of failure. So if you could narrow that down into something more specific, I think that might help get you to keep on with your working with your interest, but find one specific problem that you would like to have an AI find a solution towards. So it's really just too much to handle for you. So I think what do you mean by failure? I mean that's such a critical term to start with. You started to understand it yourself. What does a failure mean? So and you also understand it already as inspirational. So I think find a specific problem, because all of our architectures will generate failures as well. That there are successes and failures, and the next generation might find that the failure of the last generation is a success for us. So find a specific problem. I would be sorry if you just chose one that is structural, so like if a building feels like it tumbles down together, I think that would be a bit losing opportunities here. But other than that, you need to find a specific architectural problem, and then you can discuss what was the failure and how do I start to analyze what this failure meant.
If I can add to this also, because I'm a bit suspicious about the whole philology thing, especially like I can give you one example. The Pruitt Ijoe public housing project that you mentioned, that you showed, which was demolished then in 1976, was built in the 60s and demolished in 1976, and you quoted here Charles Jenks as saying that that's a failure of architecture, and I completely disagree with that. That's not a failure of architecture, that's a failure of politics. Yeah. So the architecture is not responsible alone for what people do in those buildings. That would be an incredible assumption to do about architecture. Yeah. So you have to be aware that some architecture fails for a variety of reasons. As Sandra mentioned, structural failing. Okay, that's something that you can put on the architect or on the structural engineer, if you like. Yeah. It can fail in its programmatic needs, in its programmatic design, and all this. Of course, it can. Yeah, but larger structural problems, and I mean here structure as political in a city, is something that you cannot put on architects. So I would completely disagree with Jenks here on that assumption that it's a failure of architecture. Okay.
But it's also partly our fault, as an industry, being part of it, playing with it. So
I would put it on an architectural level. I think when we talk about failure, I think it's an interesting notion, because when a failure becomes productive again, for example. Yeah, if you're supposed to make, I mean, the tower in Pisa is a good example. Yeah, because it is oblique, it becomes it becomes famous and unique in a way, and became this feature is sort of making it not a failure anymore, but now it has a new function. It's probably not the best one to walk up and down because everything is sort of weird, but it gets another purpose, and therefore I would not count it as a failure, or the failure become productive in a way. Now, if you think of a slab, for example, yeah, and the slab is supposed to be horizontal or floor, and then the construction company is not able to make it completely horizontal but slightly tilted, yeah, you would say it's a failure. But when it becomes a horizontal slab, a ramp, it's not a failure anymore, yeah, because it has a new purpose. So now I think.
But maybe that's interesting because also in machine learning, when we started our project, our mathematician said, great, we love to work with you, because normally the dumbest thing in machine learning is the precision, right? We need to have the 90%, otherwise the network is not good. Now working with you, it's amazing because also our results that have 60% precision, you say, well, it's great what you get out of it. Now, what if we say, that it's exactly that but when it's a slab, you know, in architect, in machine learning, we could say, okay, if you recognize all the slabs with 99.9 precision, you're a good network. But what if you say, well, if it's 5%, it's cool. If it's 10%, it's it. Look at Perret, right? He was drawing out all the kinds of angles and what it means for space, right? So in architecture, we exactly accept, or we're thinking without these fixed idea of this is right and this is wrong, this is a failure and this is a success. We are exactly that discipline that works with, also in designing, we're looking for the not the best, the optimized solution, but the good enough, right? We always open for compromise, we're negotiating. So what if you're dealing with very complex systems? We have to. I just
interrupt you. It's not good enough. It's better. That's what you're looking for. Sorry.
Good enough just doesn't cut it. If my structural engineer or our structural engineer sometimes tells us, you know, you're making forces wander around the building. That's not optimized. I say, well, but the aesthetics, it looks great. Let's do it. It's the structure is good enough.
Exactly. No, the structure.
That's what I meant, right?
No. The structure becomes better because the project becomes better. So that's good enough. Just does not cut it at all.
But there's one aspect which I would like to add, which was important also within the conversation of the seminar, which was the aspect to understand failure as an option, as a possibility. Yeah. Because it's really interesting, for example, that all these machine learning algorithms, everything that we've seen in AI, they do some things fantastic, but others they're really bad in. And it's funny enough, one thing we as humans can do really well, which is seeing a mistake as something that has an opportunity, that has the possibility to enrich the design, for example. This is profoundly human still. For an AI, this to make that sort of connection that something that went wrong can actually be an advantage, it does not exist yet. Yeah.
But this could be an interesting notion, don't you think? I mean,
yeah, I agree. Yes.
It's not only what the machine is doing on its own, but also what we see in it, and there is a sort of loop, sort of feedback loop in between those things.
I would also say I also think that your terminology in terms of imagination is not sufficient at the moment. I think you know, maybe it's wrong between the German and I'm German speaking, so for me imagination contains the image, right? It's in German we say the Vorstellung. It's the image that we have in our hand, the image that we generate. So it's not that it is a solution that doesn't exist. Maybe the solution exists, but the imagination of it, what does it mean? And I think we architects, are really good in the imagination of things, right? It's exactly the images in the mental images in our head. Again, I come to Rudolf Arnheim and his idea of the imagination as the mental image, even that could be very abstract. Yeah? That is not really full, that's just an abstract sketch in our head. So I think really look, I think if you take imagination and tie it down to the need of the image, and then maybe also when we look at not learning, you know, what do we learn? Like always when we look at these style transfer things, it's so funny that we seem to accept as architects that we are allowed to use style in a different meaning because it comes from image processing, and they mean with style, they mean the texture, more or less, right? But we as architects, we have a different understanding of style. Now, if you train somebody, if you would really be able to train a me style to another object, like what would that mean? It would consider you having the architectural knowledge, and then somebody who learns the machine, the architectural knowledge, and what would be the outcome then? I think maybe you even go back to your prior studies, because I think they were really strong, but then really say, okay, I'm not accepting style transfer in their understanding. I'm really trying to define what is the style in architecture, and it's for sure more than just the texture of an image, right?
Yeah, I will go just back to this idea of passive imagination, and also the problem of defining more precisely the terms. Right now you're saying passive imagination, AI creates novel solutions which are unintended or unanticipated. So for me, that, I don't know if you are familiar with Margaret Bowden, but for me, that definition sounds very much with the Creative Mind book written by Margaret Bowden. And probably it would be good for you to look there in how she's describing, in a way, creativity, or what we perceive as being creative, yeah? Because there are different types. So you can call something as being creative as something that is new, something that's surprising, or something that it's valuable, let's say. So try to look also at that aspect, exactly what it's meant to passive imagination. Because just something that is unfamiliar, we can classify as being, you know, imaginary or something. It's something that it's new only because, you know, I didn't expect the result, or why it's that creative, yeah. So I think that also falls into that side of how you evaluate things, the results, yeah. And personally, I'm more in many cases I feel that I'm more on the side of the machine than on the side of the architect. So I'm the devil advocate here. Sometimes I think it's valid that, yeah, humans, we cannot see, or machines don't see potential in certain things. But I see that also that thing happens also the other way around. Many times we don't see what machines are able to see. Yeah, I mean, there is a research paper showing, you know, do machines really see numbers? And if you're looking there, they're just showing an example where a machine identifies a number of 1, an image with a number of 1. It's identifying that as 1. And then you have on the other side, you have a noisy image, just a white noise, and the machine still recognizes that as being 1. So the question there is the machine wrong, or we as humans are wrong, like perceiving that pixelated image as not being a 1, for example, yeah. If you're looking behind the scene, like what's happening, actually the machine is understanding the relations between the pixels and the color values in the pixel, yeah. And that white noise that was generated, it still represents a 1 from this kind of relation between pixel perspective, yeah. So in that sense, I think this kind of problem cuts both ways in a way, like machines see some potential somewhere that we don't see, and the other way around, the machine doesn't see a potential where we see the potential, yeah. And I think this has to also we have to become more savvy when it comes to how we control the machines and data sets, and we really have to go into understanding the topology of the data, like the shape of the data and stuff like that. Yeah, when we start to train, when we start to input some information in the machine, we really have to understand which is the topology of data that we are going to work with. and what's the shape of it, how it's going to influence things, and so on. Yeah. So I think that then once you are there, then we can think of how we can evaluate the results from a machine perspective that really gives us also these kind of unexpected moments that we as humans will read as unexpected. Yeah. So yeah, these are just me playing the devil's advocate here.
Not so much devil's advocate. It's not much different to what we were saying all the time already. Okay. I mean, we don't deny the possibility that machines do perceive the world in a different way and add to our abilities as architects. It's just I think it's more like a dialogue, right? I mean, there's like you generate something in the computer, you get an output, it triggers your imagination, and then you change the approach and so on. So there's like this feedback loop between those things. It's not. I don't think it's a one-way street.
Yeah, for sure, for sure.
For sure, because even without AI, I mean, I think all of you and all of us have used computers to create something that is beyond our imagination. It's beyond something that we could project as a possibility. So that's something that we are pretty familiar with it, you know. So during the last decade of designing, but probably it's sometimes it's harder for our students, and also thinking about it that some started their architectural training just a year ago, so we have to consider also factors in also. But this is certainly the first generation, and here I'm really expecting something that you're taking in consideration, that you are probably the first generation to shape how we are going to design. So I think you should be very aware that you have to be careful what you state and what you say about it. Also, that's probably why all the three jurors today of us, we are insisting that you're be more precise, don't invent new terminology, but really, Matthias always tells students, I know that if you're not sure about the word imagination, what it stands for, just look at Wikipedia as a starter. You know, there you will find tons of information. Then you will find that nobody knows what it is. I mean, I did not come up with some of the projects before that were taking also consideration visualization and reality of what we perceive, what the tool perceives, you know. So because I think the machine probably captures reality much better than we can. So I think we should really rely on what the machine is telling us and not what we see and perceive. So I think
that, Sandra, I think that, but that's why I think the seminar help. I think it has that tool for students implemented, because I think I would use the reading, right? So the reading would help you to define that idea of imagination precisely. And I had, sorry, we have just Peter Handke at home, right? So, and you know, Peter Handke writes a lot about imagination, and for him, it's the elevated moment, like it's the sublime, right? It's when imagination hits reality, something new opens up. For example, and that's, for example, what I see always in this idea of deep dreaming or these things, that when these images start to collide, the presence and the potentials, right? Or you were talking, I think, about Deleuze and Quinter, the virtual. I think the imagination could also be connected to the virtual, in the sense of Deleuze. So I think if you would take your readings that you were given or you selected, really read them rigorously and stick with them, I think they would have an amazing definition already of imagination. I think.
Right.
I think that.
And I think here also, so if Quinter says that each cube is the same, it cringes me together, because as it is encapsulating how a snow crystal is formed, you know, so it encapsulates also the totally ambiguance of the icicle, you know, so the ice cube, they are not the same. Yeah, absolutely, each of them is individual, right? So that. I know what he's meaning, but the example is pretty bad. So.
There's one thing, and I don't know exactly which AI theorist it is who said it, but I actually liked it pretty much. The idea of imagination in our perception of reality, for example. And his argument is that, or the theory is that actually each one of us is basically hallucinating reality. So each one of us is in his own reality, and what we consider between us as reality is the minimum amount of crossover of those hallucinations. Yeah.
I think it's annual set.
Yes, thank you. Exactly. Yeah. So I like the idea that we're all hallucinating our own reality, and in fact, it would look for everyone different.
It's a cultural agreement we all have, you know. So we have an agreement that we understand reality in a specific way that we have been taught in school. If the time is for ours, it was the Enlightenment. We're still under the regime of an Enlightenment in understanding space, while 60 years ago, since 60 years ago, we know precisely, and our teachers know precisely, that this is not the reality. So they knew about particle physics already, you know. So Deleuze is talking nothing but particle physics. When his assistant interviewed him and asked him, "Are you talking about physics?" "Of course, I'm talking about physics. I don't care about people." But he was joking, you know. So he was the first one to really write about the physical reality, that the newest insight we have, which will also be not the right thing, by the way. So again, we have to culturally agree on something we know already will be covered as something that is not true, but might lead to some sort of reality that we could capture with the devices we have, and computers and the sensory aspect that enable us through computers and through working with these new tools that can contribute in such a rich environment, can help us to understand it, because we have to go into higher resolution with the questions we are asking, with the answers that we want to do. And we as architects the only thing we can do is we can provide it a body. We can provide those tools a body so they can manifest and people can understand what the actual reality is, what the actuality of the matrix that is surrounding us is. That's something how we could contribute. My 5 cents.
Great. Yes, and I think it's finally time to get Putin out of our face. and maybe continue with the next group. Thanks a lot, guys.
Thank you.
Thank you.
Can I just ask real quickly, can you put the author, her name of the Creative Mind book that you mentioned? Is it possible?
Yeah, Margaret Gordon. Yeah, I'm going to press name.
Yeah, she's great. She's really good. She's the grand dame of AI research, definitely.
Yeah.
Thank you.
Welcome.
So the next ones would be Dongjian, Xiang, and Jianfeng.
I'm sorry, I probably have to switch out now. I'm sorry I cannot join you until the end of the Stefan and Christina, it was for euch wieder zu sehen.
It was absolutely nice to share some hallucinations with you today.
Yeah.
Thank you. Please do that.
We already told Matthias that you have to come to our studio. Also Daniel, because we have also a project on machine learning here, a research project, and it would be great to have you for a seminar, and it would be amazing.
Cool.
Review.
Thank you.
Let's see each other soon. Bye-bye.
Bye-bye. Thank you for having
Ciao,
me.
Sandra.
Okay, I will share screen now. Can you guys see that?
Mm-hmm.
Yeah. Sean, you can go first.
Yeah, similar to the groups before, we will go through the exercise firstly and then talk about the project interest later. So yeah, first one is 2D to 2D style transfer. The style image I choose is a painting and choose different kind of contents. So it would have a feeling of impressionism painting.
Yeah, and sorry. And also here is the 2D to 2D style transfer with so I choose Stereotype combined with the style and combined with Pactala with it and Santa Pompidou to see the effect with these two architecture combining with Stereotype. So it's kind of the way they merge into the architecture and create another scenery of the architecture. I will pass to Dongjian.
Yeah, and in the first exercise, I used the Champion Church as my content and combine this with three different paintings. The first is one traditional Chinese painting, and the second one is a Starry Night, which is abstract painting, and the third one is Japanese style painting. And I use these three results to compare the different cultural paintings. How do them influence the styles of the result? Yeah, that's my part.
Yeah, second exercise is 2D to 3D transfer. I choose three pictures. One is kind of interior of a cathedral. The second picture is a landscape, natural landscape. And the third one is kind of pattern. So yeah, I create some patterns of the surface of these models.
And also here is I choose different kinds of styles with different models. So we using architecture combined with like the sphere like shape and to see the difference of how they attach to the surface of it, also the natural texture, and we can see the from our test we see the more severe part will be, and also with the more obvious kind of like cube like shape will be more to show the texture and how they attach to it. So it's so I also change with the different weights to see the difference between the texture, how the texture attached to the model, so, and also the using the facade to see that.
Yeah, and in my part, I use the pictures of the nature and the pictures of architecture, and the last picture is just a black and white pattern. And in these results, I compare them and found that the influence on the objects I choose the complex the results of the complex architecture environment may be more evenly and didn't show great ups and downs. But if I use things like the colors, the vegetables, which has obvious depths and depth, the results may be the texture on the objects may be more clear. So that's what I found. So, and at last the black and white pictures, which shows us a feeling of our sphere. It also shows great influence on the object. Yeah.
And also we did the 3D. It's a 2D Google Deep Dreaming.
Yeah, because we are interested in doing some like AI, how explore how could AI like teach AI to join in our project. So we try 2D deep dreaming, like say different kind of styles of the image, of the original image.
Yeah, here we actually choose three different types of way to use the Google Deep Dreaming, like architecture and also the city and also the painting. So here we use to use a Google Deep Dreaming to show the how different layer or the image overlap and are superimposing to the into the city or the architecture. So one it's into the New York City. So I think this one is also good to see the different spatial way to see, and also it may become another city to see its patterns or the space.
Can you go closer?
Yeah, sure.
More.
Yeah, so like this part on. So it's kind of way to, so the new imagination of the texture or and the city. So
can you go closer to the middle one, please?
This one?
No, the one underneath.
Okay. Yeah.
That one, yes. Thank you.
Yeah. Okay.
And in my part, I choose traditional Chinese paintings as the content to use 2D Google Deep Dreaming, and we are interested to see how does the AI translates different elements in the traditional painting into some language of objects like the animals or some plants. It's interesting to see how does it reconstruct the structure of the original painting, and to make something interesting. Yeah, like the butterflies. And then we are going to talk about our readings.
Yeah, I read the chapter Simulation and Mammalian Memory, which is chapter 7 of the book Philosophy and Simulation. Basically, this chapter describes how to use neural design to simulate the mechanism of the memory of the animals and humans. Like, how could AI capture the informations in the visual field and calculate different weight of the information, then have some like feedback to the reality.
Yeah, my reading is the new dark age cognition. So James Bridle is combining the digital editing with aesthetics. So it's about the key points about it is so the AI is kind of get the kind of logic that human cannot understand. So, and also AI is creating another language of them. So like face recognition, so they can recognize face, and also to use this different structure and different facial recognition to create the fake face. So, and also with a different input and all the different like smiling or the different like different emotion of it, they can combine to another one. So also AI can recomposing the language based on the existed database they have. So and the author, so the dark age is kind of the way like people have lost the control of the AI, and also the unbalance of AI and humans. So also proposed another way is like a cooperation with AI to imagine another new way of balancing and to maybe get out of the dark age.
Yeah, and my readings is written by Maria Carpo, and the title is Excessive Resolution from Digital Streamline to Computational Complexity, which talks about its time of excessive resolution that with computer algorithm, designers can capture and save the inherent discrete of nature, which transcends the normal imagination and comprehension of human. So since with the development of computational technology, people can the architectures that designers can create is from like we can design architecture with nerves, and then we can make some completely computational driven architectures, which is out of the normal imagination of human, and not only the designs, but also the technology like the 3D printing to make this complex decoration can come true, but not cost a lot, which is in sorry. So the decoration or ornament are expensive in the past, but nowadays the more decoration we want, the less we can pay for it, since we create a new logic of 3D printing, which is only based on the single voxel, but not a whole metric. So this reading is focused on the technical production skills and the computational algorithm we can use to promote our complex design. Yeah.
And our vision is more mainly based on the 2D to 2D style transfer. So it's kind of way to transfer the so we starting with transferring the Chinese traditional drawing into using the AI to draw or the transfer it. So this is the present we find. So for the traditional drawing and the artists using the 3D modeling to model these mountains, and also use the AI to redraw it. So it's an AI way to express the traditional and the drawings. So we start to think about if we can use the AI to create a certain image, or even the space, or spatial, or even the city. So we think it's a kind of way we imagine to create, and also like the here the traditional drawing, and with so they also have the precedence with using the traditional drawing as a concept to build the architecture. So we think maybe it's AI can take the chance to transfer using the coding, or the transfer it into the architecture space. So it's a kind of way to imagine the utopia or the city future. But we are questioning some part of it is it's how to make that decision, how to process it, how to create them, or the what standard can be this AI or the image to become the space to use, or become the space to for other things. So yeah, we have certain questioning about the transferring, and so also with here the using the plan. So the use transfer with the plan and to build the architecture. So we're thinking about this way to create a certain space. And Dongjian, do you want to add something? Oh, okay, I think that's basic. Oh, yeah.
Thank you. Just before I forget it, there's a little thing before we start with the review of this project. The last images you're showing right now on the lower right, yes, these ones. please in the future don't forget to put the source in there. These are
yes.
These are Stanislas Shailu's drawings.
Yeah.
Okay, thank you. In general, sources, they're all missing. Yeah.
Yeah. We will remember.
This is for a comment for everyone, by the way. All students, please. Okay, thanks.
I really like the city plans you were doing. I think there were some really nice examples, because I mean, reading them actually as part of the city, I mean, in my interpretation of what I see, there are new qualities emerging, like sub-centers, or in Vienna we would say Grätzl, but also I think in order to really evaluate, it would really help if you would have some parameters next to the individual sequences. Like, I don't know, how much green area in comparison to the sealed surfaces, or how many houses or blocks you get in comparison to the green areas, or in comparison to the length of the street network, the overall length. So I think that would give us such criteria also, not only visual criteria, but also some pragmatics, and we could judge them, or let's say match them next to each other.
And maybe in parallel, what Daniel said priorly, that there would also be a machine reading to those. What if you could machine let these plans read, and then understand when would the machine read this city, or when would it read something else, and then even look into the different scales, because when it comes to this understanding of pixels, it's different if we look at it like we're looking now, but then we could zoom in, right? And then we have another kind of information. So then probably the machine would read different things, and also human would. And it reminds me a little bit of the powers of 10, maybe that could even be the kind of a reference that you could create almost like a zoom in, a step so that, and explain. I mean, it's nice because it changes so much depending on how far you're away from it, right? That's nice. I think it's successful here.
Yeah, it's successful in my point of view, because there are new features emerging, features you haven't in the original.
Because we saw that a lot, right? We're seeing these Google Earth images now quite a lot all around the studios. And I was just reminded of Matthias and Sandra's very old Barcelona drawing, right, that you exhibited in the MAC. It's so cool because it was a completely, it was a different method, but in a way it really, reverberates a lot with that dreaming or deep dreaming. And I think but it still has this strangeness, right? It can't be detected how it was made. While here with the Google Earth images that we see now a lot in all over the world, in all studios, we always see what's happening. And you are very successful because we don't see it. There are moments when we look at these drawings where I thought it might be a carpet or it's really great, right? They're very successful. And also I think I like that you look at ground plans. I think nobody did so far in the group. But I would recommend looking at Dillenburger's PhD Space Index. It's written in German, but you have all the tools to translate it. Also, Google Translate will do the job for you. He also has some papers in English. And he was also dealing with artificial intelligence and knowledge in architecture. So what would we learn if we would learn architecture, if we would learn a machine architecture? And then he's especially focusing on ground plans. And then he tries to automatically generate ground plans. And maybe that I think that would be an interesting reference.
But it's also interesting because there's a lot of vagueness in these images. It's not entirely clear if elements of this city becoming to a house or the street or the park or is it an entire new object which is emerging now? And this kind of vagueness could be also an interesting thing to speculate about, also in terms of what's going on really when it comes to the street level, when you are inside of the city and you are immersed into it. And I also think that these new qualities, probably you cannot even isolate them properly. They are absolutely interwoven into the fabric, which I think is sort of interesting.
I think they also have a very interesting moment where they start to look into a section in a way, right, I think above the floor plans. Can you go there where you have the floor plans? So I think you were showing Sydney Opera House, and next to it you had some sectional, in a way, model approach or something. Yeah, this one's here. So I think also this, yeah, that approach, the image, the D, image D. So how I understand that it's mostly you're creating sections, yeah, and then you're almost like recording sections. So I think that's a very interesting also way to look at things, because yes, we have this kind of challenge right now. We are just generating images 2D. Then if we jump straight into 3D, it's not the best thing either, because we don't really control the quality of the space. In section, probably you have a good shot in a way to try to control the quality of the space and this, yeah, exactly, the space itself, yeah, not so much that what you can do in floor plan, yeah. So I think that kind of approach of almost like slicing or creating this kind of like sections and then aligning them and create that kind of mass, I think it's also a very interesting approach. Will be interesting to see how you create that kind of sequence of sections, yeah, and in a way how you have the AI aware of the spatial conditions that you're aiming for, yeah. Because I think that's something that would be amazing, yeah, if we have AIs that actually start to also understand somehow the quality of the space. That would be great, yeah. And I don't think that's possible with just 3D, because yeah, how you define quality of space in 3D, for example.
Well, I mean, to add to this conversation, because that's a crucial problem right now. I mean, the thing is that when you do 2D to 3D, you can either influence the exterior, or you can influence the interior. But you cannot influence both at the same time currently, at the moment at least. Yeah. I saw, I think, one student project we had in our workshop for digital futures. Actually, we had one student who was clever enough to do something like a veranda. So it was sort of interior and exterior at the same time. So like a workaround that. It kind of worked, but it's not really very well informed. And I think also that we must develop much better methods to dealing with 3D data with artificial intelligence. We're not there yet. I think it needs time to develop. Section is one option. Yeah, I think that's a possible way to go, because basically what for example, Stanislas Chailu have been doing with plants, you can do the same thing with sections, right? But then the question is, how do you transform that into a 3D object? Yeah. Or the other option, we are currently working on an entirely mesh-based neural network that includes now semantic information and labeling. And that's actually where it becomes interesting, I think, because you can start to label three-dimensional objects for example, with specific programmatic qualities. Like you say, this is a toilet, this is a living room, this is and so on. And then you add more semantic meaning by explaining what's a wall, what's a window, what's a door. But all these networks, all these kind of AI techniques, they have to understand first what the things are that they're dealing with before they can do anything with them.
Yeah, but that's interesting, because as soon as you has allocated a tag to a certain element, which says you are a wall, probably the machine learning can further alter it and improve it in its wallness.
Yes,
which
absolutely.
Then becomes to a more usable model, a more better model, which we can access better, and probably also, because to me, those fragmented 3D models at the moment are overwhelming, yeah, and I really don't know how I should approach them. I mean, they're definitely spatially very interesting, but in terms of typology, I have no clue what I should do with that.
But that's exactly, yes,
But
sorry,
if
go ahead.
you, if
go
you
ahead.
start to do that, you could, I mean, then that becomes just a starting model or intermediate step where you then evolve further something which is much more, let's say, defined in its elements and its purpose.
So probably it could be a feedback cycle between classification that you do with your results and then generation again. Maybe, I mean, that could be quite interesting. Yeah. And
But
then
it could be also
there's
that
a hybrid ontology where you say, this is a 50% wall and the 50% whatever, we don't know. You know, it doesn't always have to be 100% wall.
Yeah, that sounds interesting.
It could be also that your focus, you can switch your focus. Right now you are informing mostly the network about the solid parts like the walls or ceiling or what have you there. But it will be maybe more interesting to inform the network about the space, like define actually the space, not exactly just the walls, yeah? And then, you know, it's actually the network is outputting like this kind of layouts of spaces, not so much of walls or something, yeah? And then, yeah, you can find a way around like a different network that generates also the surrounding. But like that, at least, you know, you have a network that addresses just one task, one topic, just the space, yeah? And then you go further from there, and I'm addressing now also the walls and enclosure, yeah?
We've been experimenting with that, which is quite funny because what you get when you do what you propose, Daniel, what you get at the end is really interesting because you get like these super fat pochets of full volumes and small spaces in between, and suddenly the walls become paper thin and so on. So there's like this incredibly articulated space, and you almost feel that fatness of the walls. And actually, I'm fascinated by that. That specifically happened to us when we were working with models that are modern and Baroque, and tried to combine those, and that's what happened. So you had suddenly like these completely articulated fat walls, which were kind of nice. Yeah, it was kind of cool, but still, it needs a lot of work.
I think I completely forgot what the proposal for the project was, because your parts were so interesting. But what was the interest for next term?
So our interest is to kind of transferring like the traditional drawings.
The drawings, yeah. No, I got it, but yeah.
Or the like the plan or the section, yeah, that would be pretty interesting. Yeah.
I also think maybe you have a discussion again with Matthias, because the painting, I mean, the painting is nice, great, but I think there's again another, I mean, maybe you are very aware, I assume you are very aware of that whole knowledge that is in that paintings. I mean, for me, it would be another thing that adds to that and adds a lot more complexity. And I wonder if you don't have the question already on the table, that's very relevant for architecture, right, at the moment. So maybe, but I think that's up to you guys. I think I didn't get the Chinese painting proposal, so well, didn't understand it.
So I can a little bit so actually the Chinese painting is kind of the 2D way to express 3D dimension. It is different from the like the sketch or the oil painting, and so it's kind of way to use. So it's a little bit like the forest or the little bridge here to see the depths of the space. So so this kind of way can be transferred or converted into the architecture, or we can use the AI to calculate it, or the deep dreaming it to be another kind of space.
So the sequence, the depths of the picture.
Yeah.
The painting.
To be honest, I think we need to have a conversation rather around the aspects of plan and sections with the technique you're using as a more architecture specific problem, right? Which I think is interesting to stay within the disciplinary questions that arise from the technique. And if you can make your stand or your comment on that problem that we are currently facing in terms of using any form of neural network in design, that would be really super interesting, because the painting is exchangeable, right? I mean, I could do a Chinese painting, I can do a Western painting, I can do an Australian Aboriginal drawing. It still would maintain the same amount of information in terms of how it influences the result of a neural style transfer. More important in that aspect is rather what are you doing with the weights and so on, which is your contribution, not so much the contribution of the painting. So I think that really interrogating the problem of the section and the plan with the use of neural network techniques is a really interesting one, especially when it comes of translating that into a three-dimensional object. Do you continue using a pixel-based technique like what you're using now, which is basically like the 2D to 3D style transfer? And by the way, one thing we shouldn't kid ourselves here is that the whole 2D to 3D technique is nothing but I would say it's depth mapping, just glorified depth mapping. Yeah. So this is a technique that is already quite old. But we need to understand where's the beef in that? Yeah, like how do you really translate that into a very specific disciplinary problem within architecture? Yeah.
Yeah, and talking about that, I think it's also then interesting, and going back to those kind of urban images, it's also interesting to see in a way how you progress in a way, like almost like a sort of process. So I start to generate, let's say, that kind of deep dream. So as an architect, do you have some observations, and how those observations are influencing then the next iteration that you're doing? Yeah, it will be interesting to see that, because also when it comes to 2D, 3D style transfer, it's like, yes, once you run it first, then okay, you get some result, let's say, yeah. But then you start to understand that actually I'm interested in these features to be more highlighted. So then I'm going back and how I'm changing certain things to have those features more highlighted, yeah. So I think it will be also interesting to have this kind of process behind when you work with this kind of methods.
Great. So do you have any final comments? Because otherwise we would move on. All right. So this is then our last group coming up now. Yu-Chun and Yu-Shin, are you there?
Yeah, we are here.
Great.
So let me share my screen. So we will first go through the previous experiment about the 2D and 3D neural style transfer. And in this part, I was trying to transfer some famous paintings onto the facade or onto the windows. And these are all the results. And this painting is from Henri Matisse, and this is from Paul Cloux, and this is Mondrian's painting. And they have some different like iterations on the wall, and it creates some different images.
This is my 2D to 2D style transfer using Gaudi's design as the content and using pixel image from the pixel artist Karina Bayar as the style transfer, trying to create the collision between architecture and contemporary artist means. So yeah.
And this part is 3D neural transfer, and in this part, I was trying to like choose some architecture images or some natural images and transfer them into a cube or a tube. So these are all the results.
So as for my part, applying to natural image to architecture history, one image from Yayoi Kusama, not a lot of logic here, just trying to test on different patterns and different weights. Yeah, and the first month.
So I will switch to our proposal.
Yeah.
So this is our proposal. Like our working title is Inventing the Future. So, and Yucheng will start with the futures and different features.
Yeah, so this idea comes from the future, like different futures that emerged in the last month's interest movies and several books there. And for the next slide, Matthias has recommended, sorry, the previous one.
Sorry.
So Matthias has recommended lots of interesting movies for us to watch, and these include Westworld, Ghost in the Shell, Aquila, Tron, Ex Machina, Her, and we also has enlarged movie list includes Blade Runner, old version, and Blade Runner 2049, Black Mirror. These movies and TV series drive us to start to think about what the future would be like and what is leading the imagination toward future scenes here. And also we have some reading out of our interest for future imagination, The Brave New World and 1984 are both novels creating a dystopia world, and Adler's future world is set in a futuristic world state whose citizens are environmentally engineered, engined into an intelligence-based social hierarchy, and participants huge scientific advancement in reproductive technology, sleep learning, psychological manipulation, and classical conditioning that are combined to make a dystopian society which is challenged by only a single individual. As for the last one, Future Shock, sorry, still the previous slide. Yeah, as for Future Shock by the futurist Alvin Toffler, together with his spouse, Adelaide Farrell, they define the term future shock as a certain psychological state of individual and entire societies. The shortest definition for this term in the book is a personal conception of too much change in too short a period of time. So for the next slide. Here, the concept of futurist comes, and these movies and novels that I mentioned before, and also the readings, are in different senses in our understanding are futurists, starting to search for futurists that focus more on AI to have some more information in this field. And I found Raw Kuwal. He has put forward his emphasis on focusing technological singularity. This is what we think is quite interesting here. And technological singularity is about what we are continuing to augment our thinking by uploading more and more of our own cognition to non-biological intelligence. And this person kind of really believe that mankind is approaching an event point where existing technology is completely abandoned or human civilization is completely overturned. And the event after these event points are as unpredictable as the event horizon of the black hole. And this example is very interesting. Consciousness uploading technology may free human consciousness from the constraint of organism, and human civilization after this singularity is at a level that is now completely incomprehensive. And when we dig deeper, we started to think that things like are already the mind, and sorry. And that the mind is actually not limited to the brain, but that the mind exists in the feedback loop between brains, tools, and environments. So our thoughts shape our spaces, and spaces return this flavor. Everything we design is designing in return. When go to the next slide is digging for a future that is imagined or looking back into history. The world that we are now in is culturally defined. In the evolution of imagination, Asma writes about how truth is culturally specific and culturally defined and can change over time, and about how the imagination also evolves. So our image of the future changes over time. And it is also slippage The future image is a fluid process of time. Ideas are part of mixing and remixing a fusion of continuum of ideologies. For us, these two points can also be used to search for the database in inventing the future.
Yep. So regarding how to invent the future, or at least imagine the future, we think one way is through information or big data. So this is the first example about the spreading of information. On January 4, 2019, a new Instagram account was created and an image of a normal egg was posted, accompanied by the citation that said "world record together" and get most liked post on Instagram. And this post get 53 million likes, and it actually broke the world record. And we think this is a weird experiment that represented a new paradigm of community building, or as the epitome of the internet's absurdity, or as the embodiment of the internet's magic and truth, that anything, even the most unexpected, could become a breakout sensation. So this example aroused two questions about the internet and Instagram. So was it the power of the Instagram, or was like the internet has accelerated the information's replicability and the diversity of the results? So from this post, we think this is a kind of meme. So meme can best be understood as a piece of cultural information that pass along from person to person, but gradually scale into a shared social phenomenon. So we see that a piece of information, a small information, have the potential to become a culture or a social phenomenon in the future. So this part is another article called "Too Much Truth." It is about why scientists should become involved in those fictional areas, and it has three answers. First is film neutralizes scientific images and events within fictionalized worlds. And then the second is convincing the public that a scientific topic needs more political, financial, or scientific attention. And the third is like creating depictions of future technology that simulate desires in audience for those potential technology to become realities. So there are two important things about this part. Is like one is diegetic prototypes, and the other one is speculative designs. And the article "Design Fiction" described these two words as they seem to be an invented use of a diegetic prototype, and instead of placing a desired technology in a fictional world in order to neutralize it, they're asking the viewer to extrapolate a fictional world out of a speculative design. So we think like technology is another kind of information, and it can help to shape the future. And this part is about the image source. Basically is what our database may come from. And in the article "City as Postcard, City as Polis, City as Poem," it says we might say that in a way the city of the future is not a no place. It's a mental place. It's a place of imagination, but also a place of overlapping memories. And the article says the imagination creates the future. So we see like the imagination also can help to create the future. And this is about data. So let's go back and think, what is data? So data, the first is dimension. It means everything can be called information, and the second is automatic. So this is pretty much everything we do these days will automatically generate data which somebody can use. And the time is about like is related to the time, and data is instantly happened in the real world. And artificial intelligence is like we can use them to do some artificial intelligence work. And there are also some interesting debate about the future of data. So we should protect privacy of the data, or we should go public, or maybe more crazy to use like personal data as a monetization, and like to become a market. So I think what emerged with some of the projects and tests that deal with technological features is how technology has been a tool used and abused by power structures, but the same technology can also be a subversive tool. So, we think that like some companies have already added our information to their database, and they tagged us for advertisement of some other things. So based on this, we think we can do more, like maybe like transfer those information data onto something to design a city, or at least create some like unique themes or the unexpected frames. And through the use of memory, imagination, and technology, then we start to think how this came from. So for the memory, we think maybe we can use the pictures on the Instagram or other social medias, or even the memes. And for the imagination, we think we can look through some films or some like music or poems, like the post-digital poems. And also we can like think about the technology and add the technology to our database. So I think maybe we can like create a utopia world for a group of people, or maybe for everyone. So that's it. Thanks.
Thank you, Yushun. Thank you, Yushin.
I think I'm very sorry. I'm such an architect and such an imaginary person that I missed the images, and throughout your slides of text, I have to say you lost me. Maybe that's an advice for further presentations, that we all these unfortunately image guys, and it's really good to draw diagrams, or even workflows that you imagine. Could you go back a couple of slides to your initial studies, because also I forgot them. If I see words, it just erases everything in my head. I'm sorry.
Okay. So
no, sorry. It's also probably because it's later here that.
Yeah.
If you go back to your initial studies.
Yeah.
Yeah, before
we can go back to the mirror. So
on the mirror board.
Yeah, we can go back to the mirror board so we can see every slide.
Yeah, great. I think somehow, yeah, I think that there's, compared to the other groups, there's this missing part a little bit, where you start to translate your initial investigations into some studies, and then from that you achieve a proposal, right? So I think I mean what you're telling, I think it's fascinating on one hand. On the other hand, I always have really my issues of thinking myself, not being myself anymore. I think maybe you, when you talk about the sensation, don't forget the sensational. I mean, Matthias was writing an AD about it, right? The sensation in terms of the bodily experience, right? So one would be the sensation that's out there. So, but then let's discuss it also as the sensation in terms of the Deleuze, right? The body and its very base moods. It's not even a mood. The sensation is even lower than that. It's even subliminal. Yeah, it's something that you taste, something that you feel. It's something that even a space, of course, can give you a sensation, right? A sensation of compression, of openness, these kind of things. So maybe if you go for these everything that's outside of us and outside the mind, that all this transition between the machine and the mind, and this kind of thing that is all decentering us as a person and dissolving us more and more. Maybe you also think about the second anchor, and I think there's also, we all know in these virtual spaces, and it's interesting how well we are in that we can also connect in a way. We can have a dialogue, although we have never seen each other through to the images you present. I think humans become very good in that communication, but then there's also the lack of it. And I think the egg, you know, when we here in Austria, when the COVID crisis hit us, many people were suddenly building chicken barns in their backyards because the egg was that lost nature, right? That lost analog process of building a barn, putting in a hen and waiting for 3 months until the hen really, there would be the egg. And we were also sending such photos around our family group, the first egg. So I'm just, that's the only thing. Don't forget.
But is this going to be a theoretical thesis or a diploma? Or what are you planning for the second or the other term then?
No, it's not a theoretical. I don't think so, right? You want to do a design, or?
Yeah, we want to do a design, transfer those. Yeah.
Okay, just a question. So the last slide, you're showing memory images, then imagination equals future city. Is here the approach that you're going to scrap the internet, like Instagram, let's say, for images, and then somehow combine that information with something else, or what will be the goal here?
Oh, we can.
Yeah, sorry, go ahead.
No.
Go ahead, sorry. So I think
what we have talked about before about this part is we were kind of discussing as a whole logic here is discussing we found kind of the future inventing the future. This topic is kind of interesting here, and it's got a lot of meaning to us to imagining what is going to happen in the future. And then we started to think how people can just come into this discussion to have a future discussion, future view, future imagination. And Yuxin has got, for example, the egg there, and it's from Instagram. So we will start to think about if everyone proposing what they are proposing on the internet, on the Instagram, or what they wanted to emphasize on. So if we collect all this data into a whole and making everyone's idea get involved into a city imagination, whether this is gonna be cool, whether what kind of thing will kind of occur to the people, that a lot of imagination here will come into one, and how they're gonna collage onto each other. So this is kind of the very blur imagination for this project, the way that it's going to go ahead.
Yeah. So I think it will be very interesting. That's the reason why I was asking if you want to use it like that, because it will be interesting then to, yes, you scrap the internet or Instagram for images, but just that kind of scrapping is not really enough, because you have no, in a way, hierarchy or meaning behind that. So what you can try to look at is you can try to look at social network analysis and try to analyze, not from a user perspective who's connected to whom, but in a way, the amount of interaction certain aesthetics get, or these kind of ideas, these kind of metrics. And then that can help you in a way to sort through this kind of massive data that you might collect from Instagram, yeah? And then from there, yeah, once you have this kind of sorting and those kind of insights that you can get from the social network analysis, then maybe you can draw in a way some conclusions, how I'm going to train certain things, how I'm looking at certain topics that are expressed there, and so on, you know.
I have to add to this. I mean, one thing, what I have to say, guys, is I love your ambition, but what Daniel just described, and it's even more than what he described right now, that's actually material to do a doctorate and not a diploma project. So I think you have to be far more focused in what you try to achieve, because the scope that you're opening up is enormous. It's gigantic. Yeah, like for example, let me give you an example. If you go, we have code that allows you to scrape the internet. That's not the problem, right? So you just type in, search for example, meme, and meme, you probably will get, I don't know, hundreds of thousands of hits on images alone. Yeah. Now the next step is that you have to make your neural network understand what it's seeing. So you have to label it, and this work is normally done manually, right? So this is enormous amounts of work, and it's I'm not seeing that can become a viable project that informs the architecture discipline in a particular way. Yeah, so I think you need to focus on a very specific area. If you only go for egg memes, maybe that's gonna reduce the amount of data you're gonna get. Yeah.
Yeah, I mean, it might be that it's a very challenging, topic, and the same also the labeling of things. I mean, there are some ways how you can make certain things more automatic, but it's just that you have to learn a lot of other techniques in a way to be able to really only get to the point where you start to train a network. Yeah, there are multiple steps in between. Yeah, like I was saying, first you have social network analysis, so that will create like clusters of information, and you can in a way say this type of data has this kind of label. Yeah. Then you can use other self-organizing maps in a way to try to understand other aspects of that data, and then you label that based on that. Yeah. So then suddenly you end up with one image that has, I don't know, 5, 6 labels or something. Yeah. Because one image doesn't represent just one thing. So you end up with this kind of multiple layers. Or then once you have those layers labeled everything, then it's the big task how you train a network from there. Yeah. So,
but training networks is, for sure. But you also need to have an idea how you end up with a 3-dimensional structure, or the 3-dimensional kind of result, or how that translates into 3-dimensional. I think I don't see that at the moment. I think this is really missing out.
Maybe you also have a look, just as a reference, at Casey Rem's work at SciAC, where he uses usually a game engine, and then he has certain participants, and he also deploys some learning workflows, I think, as far as I understood. And then they're creating something together, and maybe I don't know but still you would need a design system, an aesthetic system also that. But maybe that would be what you want to, because now you want to, create these effect of the social encounter of people, and that creates something. So maybe you could also build a machine for others then to play with it I mean, look at Casey Rem's work at his studios.
I think this was the last project. I would be super thankful for the jurors to give like a final comment to the whole seminar. And that would be awesome. Thank you.
I think I think it's super interesting what you're doing. I think at the same time it's very, very ambitious. Yeah, most of what I've seen, although you are teams of 2 or 3, which is I think a good thing in that case, because you can split up work and be more efficient in that. But still, I think most of the layouts or frameworks we've had seen today were like big. They're way too big, and I think focusing on certain aspects is absolutely needed. And honestly, I also think a kind of, but that's probably maybe also too early. It goes to Matthias, but I think if you know what you would like to design with it, that would also help to make decisions. It's a difference if you're going to make a high-rise or a master plan, or landscaping or a park.
I would like to, I think, recall Sandra's statement at the beginning that you cannot make a mistake. The only mistake that you can make is ask a too broad question. And I think I start with a simple question. I think I like very much the section idea. Can I deploy sections in the translation of 2D to 3D in order to get a more architecturally informed model? Because if I ask it's still a thesis topic, right? It's probably needs more than one thesis or PhDs, but still it's a question you can frame, and then you can in the end after your thesis say, well, I achieved this and that, and of course there is more to achieve. That would be the scope what could be achieved in the future, but you can describe that very well. And I think when you're able to fix that question now, it's true, you will need a lot of time, far more time than in any conventional architectural project, because it's, you know, it's not these 3 weeks. Oh, Matthias disappears now. It's not these 3 weeks competitions mode where you in the end just draw a section in the ground plan and that's it, right? But I think it's also super exciting. You're very brave, and you can ask, you know, really dare to ask simpler questions, because what you are investigating here is really new terrain. And you're, again, recalling Sandra, you're the first generation of students, right, that are dealing that. So I think that's super exciting. You have that great infrastructure there, great instructors, and I think go for it, nail it down, focus, draw your workflow, and then really work on those simple little steps. I think that's really crucial. You need to do your little steps, you need to test, you need to get the first results and improve it. You know, it's really finding the starting point and the right question. But great, I really enjoyed it a lot.
Yeah, so I think my comments are also in a similar direction. Like, yeah, you have to find definitely that kind of driving force of the project. And then my personal take would be that you also have to have this kind of, or to learn from this kind of complexity theory in a way, and not complexity theory necessarily, but complex systems, let's say, the way that you are developing those kind of systems, or the way that they are developed. If you're looking in nature, it's the same thing. So probably also this process, already just one step in your process is extremely complex. So probably it's a good idea to be very clean, to have these kind of procedures that are very simple in a way. And then when you chain them together, they build up complexity, similar with what's happening in nature. Otherwise, it's very likely that if we jump straight into complexity and more complexity, we end up with something that we barely can control, yeah? So I think that will be an advice, because it's like AI can generate very easily noise complexity and stuff, yeah? So it's very crucial then how we control it. So like when it comes to aesthetics, okay, I'm running some experiments, how I judge the experiments of the results of one experiment. Yeah, how do I judge those? How do I move forward from there? Yeah, that will be interesting in a way to do it, because that's really going to help you also to, once you have that kind of driving force, that will help you to develop this thing in a very meaningful way. Otherwise, yeah, you might very easily slip into that kind of like interesting but not necessarily relevant architecture or something. Yeah? But overall, I think, yeah, like Christina and Stefan are saying, it's kudos to you. I know I'm also giving like classes on AI, and it's not a very easy thing for students to suddenly wrap your head around this kind of completely new way of thinking about architecture. And I mean, in itself, architecture is hard to do. Imagine plus AI. It's not that easy. So kudos to you. Yeah.
Are there maybe some final questions from our students to our jurors? Okay. Then I would like to say thank you very much to our jurors for joining us today. Thank you all students for the amazing work. We have a lot to discuss, and we will continue working on this. So very much looking forward to next week when we meet again. Yes, and again, thanks a lot to our jurors. Thank you very much. Thanks for joining us. And kudos to you guys for the work. So looking forward to continue working on this. And I think we have pretty much punctually finished today, which is great. So again, Stefan, Christina, thanks a lot. Thank you, Daniel. Hope to talk to you guys soon again. Yeah.
Yeah, let's talk soon. Good luck.
Bye. It was a pleasure.
Good luck, everyone.
Good luck.
Bye.
Tschüss, Daniel.